Good afternoon, chemistry students. No chainsaws, no leaf blowers, no lawnmowers. We're going to try this one more time here. Another chemistry lesson from the Bennett backyard. We're going to go into some molarity calculations to follow up what we did the other day on molarity, yesterday. And what I'd like you to do is just take a look at these, and probably the best thing to do is copy these down. And normally I would say take 5 minutes to copy these down. But you can pause and copy them down, obviously. So I don't need to take very long to do this. So we're going to go through each of these calculations one by one. It would be good if you had a calculator and possibly a periodic table. But get a calculator out, some paper out, and get ready to follow along. Okay. So the first problem said you're going to take 50 grams of sodium chloride and make a 2,000 milliliter solution, and you're supposed to determine the molarity of that. So 2,000 mLs, and you're going to take 50 grams of sodium chloride, put that in here, and you're supposed to calculate the molarity of the solution. So remember, molarity, M equals moles over liters. Moles of solute divided by liters of solution. And so we're going to have to do a couple conversions here before we do this calculation. First one's real easy. This is in milliliters, so we need to change that to liters. So we go 2,000. Most of this, you can do this in your head, but milliliters. And there's 1,000 milliliters in 1 liter. So we basically have 2 liters here. Okay? So we know how many liters we have, and now we need to get moles. So we're going to obviously need to convert grams to moles. So we're going to get the molar mass of sodium chloride, which is approximately 58 grams per mole. And so we're going to take 50 grams sodium chloride, 58 grams in 1 mole. Take 50 divided by 58, take your calculator out, and you should get 0.86 moles. 0.86 moles of sodium chloride. So now we can just put those into this formula here. Got 0.86 moles divided by 2 liters. Take the calculator out, and you get 0.43 molar. So that's problem number 1. Okay. Next one, we're going to take, you're going to make a 1.25 liter, 1.25 liter solution of 4.6 molar. So we know the molarity of the solution, and it's potassium nitrate. And we are supposed to find out how much potassium nitrate we're going to need to make this solution. So first we need to get the molar mass, not the molar mass, we do need the molar mass, but we should get the formula for potassium nitrate, which is KNO3. And if you add up the molar masses here, you should get 101 grams per mole. So we have a formula for molarity equals moles over liters. And we know the molarity, we know the liters. What we don't know is the moles of potassium nitrate. So we're going to solve for that. Moles equals molarity times liters, which equals 4.6 times 1.25. Take your calculator out. You get 5.75 moles of KNO3. But we need to know how many grams that we're going to weigh out so that we can make our solution, because you can't measure out moles. So we have 5.75 moles, and it's 101 grams per mole. Take your calculator. 5.75 times 101. Moles cancel, and you end up with 581 grams of KNO3. Seems like a lot, and it is. So that's the answer for that one. I would ask if you had any questions, but you don't. Okay, last problem. You're going to make 450 milliliters or 50 mLs of a copper chloride solution like we did way long time ago during a lab. So we're going to make 0.3 molar, and it's copper 2 chloride. Remember, that's the blue stuff. So let's get the formula for copper chloride. It's going to be CuCl2. Well, while we're at it, might as well get the molar mass. So the molar mass is going to be 64 plus 2 times 35, which is 134 grams per mole. Okay, now what? What are we looking for here? We are looking to figure out how much copper chloride we should weigh out to make the solution. So, but we better change the milliliters into liters, so 450 mLs divided by 1,000 mLs per liter equals 0.45 liters. So, once again, moles is going to equal molarity times liters. And our molarity is 0.3. Liters is 0.45. Multiply those together, and you get 0.135 moles of copper chloride. And we're going to convert that to grams. So you have 0.135 moles, 101 grams in 1 mole. We're going to go 0.135 times 101 equals 18.09 grams of copper chloride, blue stuff that you would need to weigh out to make this solution. And you would put that in, fill up your beaker to 450 milliliters, and you would have the solution needed for our lab that we did about 9 months ago. And that'll about do it. Thank you.